So now that we have been continuing with discussing about the different types of sets, now comes the question, is the set countable or not countable? So for example, if I take the set of vowels, I can count them because I know that there are 5 vowels in English alphabet, which are A, E, I, O, U. But when I ask a student to stand and read the set of all natural numbers, then he would only read 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth. But he cannot read all the natural numbers. It is impossible to count all the natural numbers because there are infinitely many. But when the same student is asked to count the set of vowels, he immediately says A, E, I, O, U and halts at U. So this makes me understand that the sets which are countable are finite and the sets which are not countable are infinite. Very simple definition. So there are 2 types of sets, finite and infinite sets. So let's see the different types of sets through an example. So here I see that the sets are separated through finite sets and infinite sets which we take separately, and finite sets are the sets which are countable and infinite sets are the sets which are not countable. They are infinitely many. The counting becomes limitless or uncountable is how I understand the definition. Say for example, so in this case I take set of vowels and in this case I take set of odd numbers is how I understand, because in this case when I take the example of set of vowels, I can take them as countable, which are 5 in number, and I can write the finite number of elements inside because they are countable. But here when I take the set of odd numbers, I take it as 1, 3, 5, 7, 9, so on and so forth, but I cannot count them because there are infinitely many odd numbers starting from 1 and ending with infinity. So therefore this stands an example of finite set and this an example of infinite sets. The question here comes now, is phi or a null set a finite or an infinite? So the question here is null set a finite or an infinite set? So clearly we know that a null set is nothing but an empty set which does not have any element. That implies no elements inside the set is what is defined as null set. No elements implies there are 0 elements inside. Mathematically, no is referred as 0. Therefore, no elements inside the set implies there are 0 elements inside the set. So when there are 0 elements, 0 is a finite number. That implies 0 is finite. 0 is referred as a finite value. That implies this is a finite set is how we conclude. So if I wanted to identify the set to be finite or infinite, I identify the number of elements inside the set. If the number is finite, the whole set is finite. If the number is infinite, the whole set is infinite. As taken with this example, the set of vowels is a finite set because the number of elements here is 5 and 5 is a finite number. So this set is finite and hence set of vowels is a finite set. For example, when I take set of odd numbers, the number is 1, 3, 5, 7, 9, etc. The number of elements here is infinite, uncountable. Therefore, the set of odd numbers is infinite. Is how we define the infinite set. Similarly, a null set is a finite set because the number of elements in the null set is 0 and 0 is finite. Therefore, this is a finite set. Similarly, with the case of singleton set, the singleton set has only one element. Therefore, the number of elements in the singleton set is 1 and 1 is finite, therefore the singleton set is finite. So if I take the second note, singleton set, generally denoted with this, is a finite set supported with the number of elements in the singleton set is 1 and 1 is finite, therefore this is a finite set. So to continue with the session, if I take a straight line A to B, then number of points on this line AB will also be an infinite set. If I take set of number of points on AB, set of all points, set of points on AB will also form an infinite set because there are infinitely many points on AB. So geometrically, you can identify the different types of concepts which can be connected to the geometrical part. So for example, will be an infinite set. Next, if I take a circle and this is the center and this is the diameter, then set of all possible diameters of the circle will be also an infinite set because I have all possible finite set. Set of all possible diameters of the circle will also form an infinite set, is how I understand. If I take this is an hexagon, a six-sided figure where my question is set of all diagonals of hexagon will also be not an infinite set, but this will be a finite set because I can draw infinitely many diameters on the circle. I can pick infinitely many points on the line, but I cannot pick infinitely many diagonals. The diagonals are restricted and they're countable. Let's see how many diagonals exist for an hexagon. Diagonal 1, diagonal 2, diagonal 3, diagonal 4, diagonal 5, diagonal 6, diagonal 7, diagonal 8, diagonal 9. There are 9 diagonals which connect one vertex to the other vertex. This is a finite set because totally there exist 9 diagonals for an hexagon. So this can also be connected with a polygon. Set of all diagonals of a polygon is a finite set but not an infinite set. And to identify finite and infinite sets, sometimes we need the mathematics